Hey, hi friend. So today I am going to explain about the one of the famous interview question, which is nothing but how we can convert any linked list to the balanced BST. So think that you get this is the single linked list which you will get, and you have to convert it into the BST. So if you will think about this question, this question is more about the nature. We can divide it into the recursive problem, right? Recursive problem, it means that the length of this node itself might be the n number of from 0 to n. So recursively with this problem we will divide into the n by 2 part, right? And after the division of n by 2, again recursively we will divide till its size is 0 or its size is 1, right? Till that we will divide, and then after that we will link the left and right limit accordingly. Okay, so means recursively basically we will try to merge it. So if you will see how this structure it will be, so like see, this is the linked list, and here I take in one node ref in the just this is the reference. Okay, node ref, it means that it will keep the one node link this pointing to this any one of the, in the beginning it will point to the beginning of the node. Okay, now here what I will do, since I said it is a recursive in nature, so we will divide it recursively n by 2 problems, and till size is what, it's less than 0, till that we will divide less than equal to 0, right? This problem, and recursively we will call, and we'll try to find out with respect to any node what will be the left child, what will be the right child. So whatever the left child and right child is there, we will try to find out, and moment when it will be, we will just we will find out what is the element. Suppose that this is the x element and a and b, it will be the child of x. Then in that case again we will move this references to the next node. Okay, like that we will recursively move the head basically. So if you will see here, whole problem we will divide into the small part, then recursively we will reach up to 1, right, last node. And if you will see up to this node, once we will reach it, then at this point what it will be happens is recursive call, it will be apply whenever it will be apply, it's means size by 2, then 1 by 2 equal to 0 0. So their child, one child, it will be the null basically, and then moment when it will be go to the here, means node reference recursively, then in that time this it will be the left child. So it means that there before left child it will be linked to this with 2 whenever the size of the problem equal to 2. Right child equal to null because their size is only the problem size is 2. Similarly, one ahead again we will go right side, because see, you think like 2 raised to 0, 2 raised to 1, 2 raised to 2, right? Whenever we will move ahead again, then it means that it will be 3 and 4 all, it will be right, means size upon 2. Since I saying ki in every call we are doing size upon 2. Okay, this problem. So whenever the recursively, then in the call stack basically recursion, when it will be, then in that point this 4 node we have to add in basically. So in that case what we will left node we will get the 2, and right node we will get the 4 up to this. Okay, again what will happens, Again next turn, whenever we will get it, this one, right? It basically, and at this node, at this point, we have to add in the all the. So I hope so you got it. So how we will do the recursive? So here link it will be there, and write, since recursively right portion is also going to call. So in this case it will be recursively, it will be build this kind of linked list. So let it jump on the code. So code wise, if you will see here, like I said, key node reference is nothing but it will keep the, in the beginning it will be initialized with the current head of the node, or the current head of the linked list, and then after that to balance BST. To balance BST is nothing but it's a current size of the linked list. Like here in this example, it's a 9 size, right? 1 to 9. So it will be the 9. Recursively, I try to find out the what should be the left of this current node, basically. And since this is a recursively, it will be called, then it will be reached up to 1. And up to 1 again, it will be called to the next when the size equal to 0. In that case, this condition it will be true, and it will be return the left equal to 0. Similarly, right also it will be return the 0 whenever it will be come back size equal to 1, then size minus size by 2 minus 1 equal to 0. So right also will be the 0. Okay. So when the problem, our linked list size is the 1, linked list size, again I repeating, whenever linked list size equal to 1, then it in that times our thinking is like this. If the 1, it will be, what will be the, how we will convert it into the balance tree, right? Balance BST. So in this case, we will see key this value, both value left and right equal to null. Okay. So we create 1, and then recursively what it will come again, it after the linking it will become again at this level. At this level it will come back, and we'll see ref equal to size upon 2. Size upon 2, it means that from 1 to 4. In this case, whenever it will be recursively call, right? Recursively call, it means that what? It will be reached up to 2, right? So 2 means moment it will be come back recursively pop up, means you know about all the how the recursion is work. It work into the stack, right? Like this. In this stack, it always work in this stack, right? It always work in this stack. So whenever it will, I saying ki whenever it will pop, next pop will be happens. So in that case, again the left it will be means left node will be the 1, it will be returning, and 2 it will be the current value. And whenever it will be called to the right, it means that there is no, it will be return the null only, right? I hope so you got it, right? It will be null only, because we have the only the problem is only 1 or 2, right? So right equal to null, left equal to 1. Again it will be go back, and it will be whenever it will be this here, means 2 raised to 2, means size equal to 4. So in that case our head equal to 3, and in that case we will get the 4 as a right node. So similarly, if you want to run it, see here, for 9 we called. Okay, now if you will see the size equal to 4, size equal to 2, 1, 0. Now size equal to 0, size equal, sorry, 0 it is called, is size equal to 1. So what is the head value? Head equal to 1. It means that their left and right both will be the null. If you will see here, left value, left equal to null, and right also it will be null. Okay, so left right of 1 equal to 1. Again it recursively it will be called. And what is the head this time? This time head equal to, if you will see, this time head equal to 2. Okay, and since head equal to 2, here you don't think because this is this up to this next is the part of the linked list. Okay, so don't confuse with this, but think that head equal to, since head equal to 2 means this portion we are identifying. Okay, this portion, now it call to the balance BST. So here if you will see, left equal to 1, left equal to 1, and at this position what are you doing? Head dot before equal to left. It means that head dot before equal to, it means that we are cutting down this one. Okay, we are cutting down this basically at this position, head dot before equal to left. So here if you will see, now our head is what, 2, and before next is null and before equal to 1. Similarly it will be go up. Now this time size equal to sorry, what is the size equal to null, because recursively it called, right? They are trying to search it the right node, right? So data equal to 4 and 5, because what happens here, it linked to the 4 and it go, if you will see recursively, what is the data it is returning? It is returning the 4. It means that this one recursively I am saying about this. What is the left and right of this child basically recursively? You got it, right? Means whenever it will be reached up to this position, then again it will be applied for 2, again it will be applied for 1. It will be try to get the left and right value, and similarly if you will see here, it means that 7 8 next. Okay, so I hope so you got it. So if you will see it here, then it is nothing but it will be returned the 1 to 9 after the, if you will see it here, then here we have got it